Let me walk you through an example of creating a sound from an original concept for a spectrogram. Here I have a little cartoon face with a smiling man and a little French beret. It has a total of 9 partials, where each partial is a straight line segment. What I want to do then is define a total of 4 points, and this will be true for each line segment. So we would have the start time, the stop time, the initial frequency, and the ending frequency. These 4 numbers then are sufficient to define both the frequency behavior and the time behavior of the partial. All right, so I do this for each of the 9 partials on my diagram. From these, I can create an array of the 4 points. Ultimately, I would have a 2-dimensional array where I have 9 segments, each with 4 values per segment or per partial. I can then loop over this array, effectively looping over all of the partials, and then create the sinusoidal partial for each one, and then add those up to build the sound. That's the essence of additive synthesis. It's also critical that we start with an audio vector populated entirely by silence, or by zeros, and then we can simply add in each partial. Now, my general approach for designing the frequency and amplitude trajectories of the partials is as follows. We need the frequency. In this case, we see it takes a little bit of a drop. What I'll do is first set up a constant frequency of F1. During the range where we need the partial to be active, I will drop that down to F2 and then remain constant from that point. Then it's the amplitude trajectory that causes the partial to turn on at the right point, persist for a little bit. Let's try to get the drawing a little better. Persists for the required duration, that would be our T2 minus T1, and then go back to silence from that point. So the partial, probably if it's an abrupt amplitude transition, you'll get little artifacts that you probably don't want. So I recommend tapering those just a bit. So let me illustrate what I've got here. I'm reading a spreadsheet for each of my partials and kind of following the procedure that I just outlined. Let's try that again. Well, let's take a look inside the VI here. Inside my overall loop, I'm creating my frequency and amplitude trajectories. Here I've pulled out the 4 different values that I needed from the spreadsheet back here. So again, I loop over all 9 partials in my example. Here I'm converting my one-dimensional linear segments into intensity, and then using that to drive my general purpose oscillator. I then add that sound to all of the accumulated sounds generated earlier. Also, it's important to normalize your results, since usually when you add things up, you'll get values larger than 1. So you need to normalize to make sure the audio lies within the plus and minus 1 range.